Epoxide formation and opening. To form one, we'll have two ways. They will both start from an alkene. The first one you learned was MCPBA. That is meta-chloroperbenzoic acid. So first of all, we'll draw benzoic acid. That's this guy right here. But it's perbenzoic acid, so actually the per means an extra oxygen, so it's a perbenzoic acid. Metachloro, this is ortho, this is para, this is meta. So it gives you a metachloro perbenzoic acid. But all you really need to know is that the whole thing is a per acid. The per acid is what's going to, per acid is what is going to make the epoxide. So instead of MCPBA, what we could really just do here is RCO3H. That is the general formula for any per acid, and I'm sure you can be tested on any of them. But what we're going to end up with here is an epoxide. The stereochemistry of these things I don't believe matter because we never really went into great detail with it. The other thing we can do is a dihalogen and some water. That will give you the halide on one side and an OH on the other. And if you smack that guy with some sort of base like NaH, you'll deprotonate this H here. You'll get an O- here. You'll do like a substitution reaction and get your epoxide that way as well. Those are the two ways we're going to make an epoxide. To open an epoxide, I'm really bad at this. To open an epoxide, oh god. I'll just edit that out. To open an epoxide, you could either hit the sterically hindered one or the sterically open one. If the conditions are not listed, for example, if I just said CH3MgBr, which is just a Grignard carbon nucleophile, so that's treated as CH3 minus MgBr plus. The nucleophile comes into the most accessible spot, leaving you with, so the two electrons in this bond here are going onto the oxygen, and you're opening it up here. So that's the methyl you just added, and then your O- is there. And then if you just work that thing up, you get your alcohol. If you're in acidic conditions, what's going to happen? If you're in acidic conditions, so there's a proton around or a Lewis acid like aluminum something, but you'll probably see like HCl or HBr or something, maybe H2SO4. This lone pair is going to grab this guy. You're going to get a positive charge on your oxygen, and then the epoxide is going to spontaneously open itself. Either these two electrons will neutralize the oxygen, or these two electrons will neutralize the oxygen, and the one you're going to pick is going to be based on the most stable carbocation. So that's going to be right here. So we're going to break this bond, put it up on there. That'll give us a carbocation right here, and our alcohol on this side. And then your nucleophile will come in and open that. If you don't want to attach anything to the epoxide and you just want to open it to an and you just want I hate this pen. If you just want to open it to an alcohol, you just smack that thing with lithyl and then workup, and then you'll get just the alcohol like that. So this is the H from the lithal, this is the H from the workup. Nucleophiles you can add to this, probably just going to be a Grignard, maybe a deprotonated alkyne. But yeah, this is what we're going to be using epoxides for.